Okay, so this is solving systems by substitution. The first method is when both equations are already in y equals, or they're solved for one variable. So it doesn't necessarily have to be both solved for y, maybe they're both solved for x. It's the same steps. So the first thing we're going to do here, it says, so they're both y equals 2x minus 3 and y equals negative x plus 18. So set equal to each other. So we're just going to put 2x minus 3 equals negative x plus 18. So that's the first step. Then we got to simplify and solve for x. So I have 2x minus 3 equals negative x plus 18. I'm going to add the x to both sides. Get 3x minus 3 equals 18. Add 3 to both sides. So then I'm going to get 3x equals 21, and I solve for x. So x is going to equal 7, because 21 divided by 3 is 7. Now I'm going to substitute x in for x, or 7 in for x, in one of the first original equations. I'm going to do the first one. So I'd have y equals 2 times 7. I'm plugging the 7 in for x because we had solved for x, minus 3. Now we have to solve for y. So y equals 2 times 7 minus 3. That's 14 minus 3. So y is going to equal 11. So my solution is going to be 7, 11. And I can check this by plugging that in. So I'd have 11 equals 2 times 7 minus 3. 11 equals 11. That works out. I could do 11 equals negative 7 plus 18. 11 equals 11. So it checks out for both of those. In this example, y equals 2x plus 1, y equals 2x plus 1. So I'm going to put them equal to each other. Now, they are exactly the same. So if I were to subtract 2x from both sides, I'm going to get 1 equals 1. So that means there's infinite many solutions because it equals itself. If it would to be equal to like 1 equals 4, that'd be no solutions because 1 does not equal 4. All right, so the next one is when one equation is in standard form and one equation is solved for one of the variables. So this is 8x plus 4y equals 12 and y equals 8 plus 3x. So I'm going to substitute for y. So I'm going to plug everything that y equals in for y of the other equation. So I'm going to have 8x plus 4 times 8 plus 3x equals 12. Okay? All I did was I plugged this y in for y. Now I'm going to have to solve it, so I'm just going to kind of put these two together. And I'm going to distribute, so I have 8x plus 32 plus 12x equals 12. Combine like terms, so 20x plus 32 equals 12. Subtract 32 from both sides. So 20x is going to equal negative 20. Divide by 20, x equals negative 1. Now I'm going to plug that back in, substitute x in, or substitute negative 1 in for x of one of the original equations. I'm going to use the second one because it's easier since we're looking for y. So y equals 8 plus 3. I'm substituting negative 1 in. So then I have to solve for y. Y equals 8 minus 3, so y is going to equal 5. So my point of intersection, my solution is -1, 5. Now here are a couple more examples that we're going to do just so we can get the practice in. I would recommend pausing the video, doing the problem, and then going back to the video. So we're not going to do 4, we'll do 1, 2, and 3. So both of these are y equals 2x plus 1, y equals x plus 3. So I'm just going to set them equal to each other. So 2x plus 1 equals x plus 3. I'm solving for x. Subtract x from both sides. So I have x plus 1 equals 3. Subtract 1, x equals 2. Now I'm going to plug that back into one of these original equations. So I'm going to say y equals, I'm substituting 2 in for x, so 2 plus 3. So y is going to equal 5. My solution is 2, 5. Now this one, x is already solved for, so that means I'm going to plug substitute -3y in for x of the other equation. So I have -3y plus y equals 6. -3y plus y is -2y equals 6. Divided by -2, y is going to equal -3. And then I substitute -3 back in for y for one of the equations. So I'm going to do x equals -3 times -3. So x is going to equal 9. So my solution is -3, 9. And then finally, number 3, like I said, we're not going to do number 4. I'll show you number 4 just so you can see what it looks like when one of the variables isn't solved for. But in this particular one, I have 3x minus y equals -2 and y equals 3x plus 2. So I'm going to substitute 3x plus 2 in for y of the original, the first equation. So 3x minus quantity 3x plus 2 equals -2. So I have to distribute that negative throughout. So 3x minus 3x minus 2 equals -2. Well, 3x minus 3x is 0, so I have -2 equals -2. So that's infinite many solutions. And finally, for this one, I need to solve one of these equations for one of the variables. So since y does not have a coefficient, we're going to solve that one for y. So 3x plus y equals 5. Subtract 3x from both sides. So I have y equals 5 minus 3x. Now I'm going to take this and substitute it in for y. The second equation. So 6x plus 2 times 5 minus 3x equals 1. 6x, I got to distribute, plus 10 minus 6x equals 1. 6x minus 6x is 0. 10 does not equal 1, so it's no solutions.